Okay, this is the transformation review. I'm going to go over all the types of transformations that we did in this class. The first one we did was a translation, which was also known as a slide. Then we did reflections, which we used the word flip. A rotation, which was a turn or a spin. And then we had a dilation, which was like zoom in and zoom out. Okay, so I'm going to give you a graph. Here's an image, and I'm going to show you just an example of each of these. Not a specific one, just a generic. Okay, this would be a translation. Same shape, just slid to a different spot. This would be a reflection. Okay, same shape, just flipped across, in this case, the y-axis. The next one is a rotation. This one's just turned 90 degrees. And then a dilation. Just made bigger. A dilation could make it bigger or smaller. It could zoom in, it could zoom out. Okay, so these are our four transformations. We have a translation, because this one just slid to the left and up and turned into the blue one. We have reflections, because this one just flipped over the other way. It's like it's looking into a mirror. We have a rotation. This one just turned down. And so now this front end is pointing down. It's turning around 90 degrees. And then a dilation, which in this case is just getting slightly larger. Now we're going to look at each one of them in a little more depth. Okay, first we'll look at translations. Okay, the rules for translations, as far as the coordinates go, what's right means add to x, left means subtract from x. Up means add to y, and down means subtract from y. Okay, so now if it said to translate triangle ABC, and in this case right 3 and down 2, and then it gives me the coordinates. Okay, if I want to use the coordinates, I need to use my rules. Okay, and the rules above are nothing new. We've done all this before. This is just reviewing, but it should make sense that right I would add to the x because I'm moving upward on the x-axis. And left, I'm moving down the x-axis, so I'm subtracting. Up, I'm going up the y-axis, so I add to y. And down, I'm going down the y-axis, so I'm subtracting from y. Okay, so if I've got my coordinates, I'm trying to find A prime, B prime, and C prime, so that I find my new coordinates. Okay, I know that since it's going right 3, I'm going to add 3 to the x. So I'm just going to take each of these x values and add 3 to it. So negative 2 plus 3 is 1, 0 plus 3 is 3, 1 plus 3 is 4. Okay, then it says down 2, which means I'm going to subtract 2 from all of the y coordinates. So 2 minus 2 is 0, 4 minus 2 is 2, 1 minus 2 is negative 1. So these are my 3 new coordinates, and this is the location of my translated triangle. So now I'll give you the graphical representation of that. This is the original triangle. And if I didn't want to use my rules, I can just slide this. This one's the most simple to do on the graph. I'm just going to move. I'm going to start with A. I'm going to move it to the right 3 and down 2. So I go right 3, down 2, and there's A prime. I do the same thing with B. Right 3, down 2. There it is. And C, right 3, down 2. There's C prime. Now, if you notice, these points that I used for my rules, that I got from my rules, are the exact same points that I got by moving the graph. It does not matter which way you do it. Either way, you get the same answer, as long as you answer whatever the question is asking for. If it asks for the graph, then you need to find the graph. If it asks for the coordinates, you need to find the coordinates. Okay, now we're going to look at reflections. Okay, the only reflections we'll be doing are over the x and y axis. So the only two rules we need are for over the x and y axis. When you flip over the x axis, you change the sign of the y value, and you do nothing to x. When you flip over the y axis, you change the sign of the x value, and you do nothing to the y. Okay, so now we're going to reflect triangle ABC over the x-axis. Okay, there's A, B, and C. And since I'm reflecting over the x-axis, I'm going to use this rule. All I've got to do is change the sign of all the y's. That's it. So A prime, B prime, and C prime, all I have to do is nothing to the x's and change the sign of all the y's. So that 4 becomes negative 4. The 3 becomes negative 3. The 1 becomes negative 1. If any of these were already negative, they would have become positive. I'm just changing all the signs. And so this is the location of my reflected triangle. Now again, graphically, there's A, B, and C. So there's my triangle ABC. Now, when you're reflecting on a graph, since I'm reflecting over the x-axis, I count how far something is away from the x-axis. A is 1, 2, 3, 4 away. So A prime is 1, 2, 3, 4 away on the other side. So there's A prime. Same thing with B. B is 1, 2, 3. So 1, 2, 3, and there's B prime. And C is 1 away. So C prime is 1 away. And there's my reflected triangle. Same exact coordinates that I had from the rules. So it doesn't matter which way I do it as long as I answer the question. Alright, now we're looking at rotations. Okay, the first thing you need to know about rotations is every 90-degree rotation switches x and y coordinates. Okay, so each time you go 90 degrees, you switch x and y. Then, if the 90 degrees is clockwise, you change the sign of the second coordinate, and this is after you switch them. So you change the y, the new y. Okay, you just change the sign, and you do nothing to x. Okay, similarly, if you're going counterclockwise, then you're going to after you switch them, change the sign of the X. Okay, so if it's clockwise, 90 degrees, then you're going to change the sign of the new Y. Counterclockwise, you're going to change the sign of the new X. And if it's 180 degrees, you're going to change both signs, the sign for Y and the sign for X. Now, you might also notice that there's no 270 here. Well, that's because if you don't want to, you don't ever have to go 270. Because 270, let's say 270 clockwise, is the same as 90 degrees counterclockwise. So you can just do that. Or 270 counterclockwise is the same as 90 clockwise. So you can just do this. Okay, so this is all of the amounts of rotation that you will have to do. So now we're going to again rotate triangle ABC. This time we're going to do it 90 degrees clockwise. So here's an A, a B, and a C. Okay, so now we're going to look at this rule. We know we're going clockwise, 90 degrees, so I'm going to be using this rule here as well as this first rule. You will always be using this first rule and then one of these others. Okay, so 90 degrees tells me that I'm going to have to switch the X and the Y. So I'm going to write all these down and just switch all those numbers. So 1, 4, I have 1, 4, that's going to become 4, 1. I have negative 1, 4, that's going to become 4, negative 1. I have 2, negative 1, that's going to become negative 1, 2. Literally just switched X and Y. Okay, so that was the first rule. Now the other part, the 90 degrees clockwise, tells me I now need to change the sign of all my Y values. So I've got to change the sign of all these numbers right here. Okay, so I'm going to go through right here. I've got to change this sign, and this sign. So that's one's going to become negative 1, the negative 1 becomes positive 1, the 2 becomes negative 2. Now I don't need that positive sign, so I can take that out. And that is my new location of the rotated triangle. Okay. Now, again, graphically, I'm going to plot A, B, and C and draw my graph. Now, a lot of us learn to turn our paper, and you can still turn your paper if you turn your paper 90 degrees clockwise and then write down the coordinates where it looks like they are. You'll actually be writing down these coordinates here. And then when you turn your paper back, you can graph it and you'll be done. Or you can look at where the points are. Okay, I know this is going 90 degrees clockwise. That means A has got to come down here somewhere. And I know since it's 1 away from the Y, it's going to be 1 away from the X. And since it's 4 away from the Y, it's going to be 4 away from the X because they have to switch. So that puts A prime right here. The same thing with B. B is 1 away from the Y, but to this side of it, so it's going to be 1 away, but on this side of it. And it's also 4 away from the X, so now it's going to be 4 away from the Y. Okay, so there's B prime. Okay, once I had A prime, also I knew that B prime was just going to be 2 spots to the side of it, because B was 2 spots to the side of A. Alright, and then C, I can see is 1 away from Y and 2 away from the X. So it's going to go 90 degrees and be 2 away from the X and 1 away from the Y. So there's my C prime. And I can connect it and there's my rotated triangle. And last one, dilations. Okay, these are the most straightforward. There is only one rule for dilations. There's only one thing to remember. There's only one thing to do. And that's multiply by the scale factor, which is K. If you multiply everything by K, you're done. That's the answer. So we're going to dilate triangle ABC by K equals 2. So the scale K equals 1/2. So the scale factor is 1/2. So you're given A, B, and C again. And we need to find A prime, B prime, and C prime. So all I've got to do is multiply all of those coordinates by 1/2. Okay, so I'm going to start here. 4 times 1/2, and if you need to use your calculator you can, that's fine. But remember that times 1/2 is the same as divided by 2. So 4 times 1/2 is 2. Then I go to the next 4. 4 times 1/2 is 2. Another 4 times 1/2 is 2. Negative 2 times 1/2 is negative 1. 1 times 1/2 is 1/2. And 2 times 1/2 is 1. So these are my coordinates. Now, I'm going to show you the graph again. So I'm just plotting A, B, and C. And this is my original triangle. Okay. Now, it's a whole lot easier to do dilations using K and all the coordinates and just multiplying. But again, remember, this is always dilations come from the origin, and they always stay in line, and K just tells you how many times as far it goes. So everything's going to be half as far. Okay. So, since A is over 4 and up 4, it's now going to only be over 2 and up 2, because that's half of 4 and half of 4. So A prime is going to be here. B is over 4 and down 2, so it's only going to be over 2 and down 1, because that's half of both of those. So B prime is here. And C is over 1 and up 2, so it's only going to be over 1/2 and up 1. So there's C prime. Now if you notice, each of these, the C and the C prime, and the A and the A prime, and the B and the B prime, each pair lines up with the origin. I could draw a straight line from the origin through C prime, that went through C, and from the origin A prime and A, from the origin B prime and B. All straight lines. Okay, so then I connect them, and that's my dilated triangle. Notice this time it happens to be smaller than the original. So that's all 4 transformations that we did this year.